Hello everyone, welcome back. In this session, I am going to explain about the basic thermodynamics, fundamental concepts and definitions. As a part of the fundamental concepts and definitions, I am going to explain thermodynamics definition and scope, macroscopic and microscopic approaches, some practical applications of engineering thermodynamic systems and thermodynamic system. Here, the thermodynamics means, thermo means heat, dynamics means transfer of heat, and causes for the transfer of heat and its effects are taken into consideration. Actually, here the energy interactions taking place in the thermodynamics. During that energy interactions, what are the happenings are there? What are the changes, the conditions, change in the conditions taking place? All the things we are going to study. Therefore, the thermodynamics branch, whatever we can say that its definition, thermodynamics is a branch of science that deals with the energy in all its forms and the laws governing the transformation of energy from one form to the another. The forms of energy are mechanical, thermal or heat, chemical, electrical, etc., in which these form the energy exchange will be taking place. The thermodynamics deals with the behavior of gases and vapors, that is the working substances and subjected to variation of temperature and pressure, and the relationship between heat energy and mechanical energy, commonly referred to as work. The energy transformation takes place when substance undergoes a change from one condition to the another in a process. The processes are heating or a cooling, and expansion or compression in the cylinder, or passages with the or without production or supply of mechanical work. Here all the changes taking place, and that condition we are going to study there. Then here, during the study, whatever the system we are going to take into consideration, and whatever the energy transactions and what are the changes happening during the energy transaction we are going to study, and there whatever this approach or whatever the point of view we are going to study for this system, that is the two types of the approaches are there. One is macroscopic, another one is a microscopic approach. In the macroscopic approach, whatever the happenings taking place for the group of molecules, whatever the changes taking place during the whatever the system change, during the process, that we are going to study here, and that is called as a macroscopic approach. The description of a system or a matter using a few of its measurable bulk properties constitutes a point of view called macroscopic. Here whatever the changes taking place at the group of molecules, those are in terms of the measurable properties. The measurable properties are pressure, volume, temperature, etc. The state or a condition of the system is completely described by means of group of molecules or a properties of the system. Such properties are called macroscopic properties, and these describe the system from the macroscopic point of view, or classical thermodynamics. That macroscopic approach also we can call as a classical thermodynamics. The study of the behavior of the gases described by summing up of the behavior of each molecule or atoms, even electrons, is microscopic point of view or a statistical approaches. During a thermodynamic process, whatever the happenings are there, those are considered as the molecular level, and the total behavior will be the summing up of the behavior of each molecule or atom or electrons are taken. That is, individual molecular level happenings are considered, and those are sum up to the behavior of a system. That is called as a microscopic point of view. That's also called as a statistical thermodynamics. There are some practical applications of thermodynamics. There are many applications are there where we are going to take into consideration as a thermodynamics. As I mentioned in this one, energy transfer where it is taking place and its effects and what are the that condition change will be taking place, those are considered as a thermodynamics. In all the energy transfer systems, there the thermodynamics is the base for the study. And where the fluid flow, heat transfer is there, that will be the thermodynamics application. The first one is the steam power plant. In the steam power plant, the whatever the chemical energy from the fuel will be converted into heat energy, and that is transferred to the steam, and that from the steam the heat energy it will have, then it will be converted into mechanical energy. Here the fluid flow and heat transfer, there is energy conversion, both will be taking place, and that's why it is an example of the thermodynamics. Similarly, internal combustion engine, here the chemical energy of the fuel will be converted into heat energy, the heat energy will be converted into mechanical energy. And next one is the gas turbines, and here the gas which is having the heat energy in it one, when it flows through the turbine, the heat energy will be converted into mechanical shaft power. In all the cases, here the heat energy will be converted into mechanical energy. Okay, those are the many applications where the heat energy or some form of the energy will be converted into other form of energy. That energy transaction is an application of a thermodynamics. Next we will take that is to study the thermodynamics, we are going to consider a system. Okay, that means where the energy interaction is taking place, that will take as a system, and the system definition we need to take. In the analysis of energy interaction, it becomes convenient to define and restrict a study to a system. For the system only we will study, and whatever is happening to the system we are going to study, and those are represented. And what is meant by system? System is a quantity of matter or a specified region in a space where the transfer of energy and or a mass is to be studied is known as a system. Then in that system, everything external to the system is called surroundings. Here, this one, whatever the quantity of matter or a region in a space, okay, on which that one whatever the study is carried out, okay, that is called as a system, and everything external to this system is called as a surroundings. And the system and surroundings are separated by a line called as a system boundary. And system, surroundings and system boundary together constitutes a universe. And here another is example, this line whatever the separating from the system and the surroundings is there, that example is taken. Here this is the internal combustion engine where inside the gas is enclosed, and that is taken as a system for the study. And whenever the movement of the piston is taking place, there change in the pressure and temperature is taking place, and that during the exhaust stroke the gas is going out. Even though that is having some quantity of the energy in that, then the imaginary, the convenient boundary is taken like this. Actual boundary should be taken this one. During the flow process, in that one, like will be taking imaginary boundaries. The boundaries whatever are there, this may be fixed or a moving, and that's why this is the real boundary and this is the imaginary boundary. Actual study we are going to take this boundary line, but this is actually it may be there like this. Okay, thanks for watching. If you like, share, subscribe and comment.